Hello everyone, welcome to Practical GCP. Today I will be covering a system design topic on how to snapshotting data using PubSub and Datastore for efficient API serving. So while I'm talking about this, we'll also be encountering some issues with why order of events does matter in this scenario. And especially this is one of the most interesting topics I'll be talking about in depth about distributed systems. So first of all, I'll talk through the design and showing how to actually use these services we talked about to get data from different data sources into Datastore. And immediately after that, I'll be walking through the order of events problems and why this actually matters in our design. The order subscription for PubSub is a unique feature for PubSub that allows us to send messages in a specific way to get them come out of subscriptions in the correct order. But however, the challenge with analytics operations and some of the use cases that I will be covering today, I'll be explaining why the order subscription for PubSub isn't sufficient to solve our problem. And I'll also be offering a solution by combining the logic and the transaction support of Cloud Datastore to how to overcome that. And in fact, this is actually an alternative to order subscription for PubSub, and it does not need order subscription at all in this scenario. Okay, let's crack on. So let's look at the design first. So if you look at from the left to the right, the real-time systems, and typically you get upstream systems that can publish events into the PubSub topic, right? So this is a very common use case. You get events published in there, and then behind that, you can have a cloud run service as a push subscriber writing the data by key into Datastore. What write by key means is, let's say you could have a customer that has a ID, you could have an order, could have ID. Those are all your keys that you put into Datastore. So you can track the status update of those orders, of those customers, to then, when the API lookup happens, it will be looking up by those keys, right? So that's how it works. On the bottom left, this is where the analytics operation world happens a lot more these days. So you typically have dbt or Airflow that are maintained by data engineer and analytics engineers to run batch jobs or near real-time batch jobs to create data models in BigQuery in the Google Cloud ecosystem. So this is very interesting because, and after that, what the business typically wants to do is to also use the same data models to serve APIs. So the approach here is utilizing one of the new services called Cloud Run Jobs as part of the Cloud Run ecosystem. So in this case, we can run this cloud scheduler hourly, get the data, track the delta, publish it in the forms of events into a PubSub topic. And then after that, it'll be the same as the real-time processing for using a Cloud Run service with push subscription to get the data by key into Datastore. Right? Those are the two approaches. One deal with real-time systems, one deal with real-time systems or batch kind of daily systems. But at the end of the day, their all kind of data goes into Datastore for consumer front-end API serving. So there's two interesting problems in here. Number one, the issue in here typically is obviously you can't use BigQuery to serve APIs directly. So you need to move that data somehow. So you might be wondering why I'm actually adding a Cloud Run job in here to send it to PubSub. Why can't I just send directly, do a SQL, compare the delta and send it directly into Datastore? So keep in mind, if you do it like that, you'll do it in a single threaded or single process, right? You cannot distribute the workload. Sending data into a PubSub message queue in the form of events is extremely cheap and efficient. So you can basically just look at the delta in here, export it, and then send it into the PubSub topic. And then behind the scenes, with the Cloud Run service and push subscription, you can scale this massively and then to write into Datastore all in parallel. So this would allow you to solve the scaling problem of if you use the BigQuery directly with the Cloud Run job to send it to Datastore, it would not be anywhere near as efficient. The number two is the ordering issue, right? So if you think about when you have especially the push subscriptions with Cloud Run services, because these are HTTPS requests and writing to Datastore. So there's no guarantee on which worker the Cloud Run service will be delivering the request to, right? So it could be many of these happening at exactly the same time, and then you create a contention in Datastore, therefore your message could get out of order. In the next page, I'll explain exactly what I'm talking about here. If you look at this scenario where order of events matter, so assume this is kind of a fulfillment system, like we're buying somewhere something from a e-commerce website, right? So where you need to track the status of the order. This is an extremely simplified situation, but you get the idea. First of all, you buy something, it creates the order, right? So the order is in a created state, and then the order is very quickly finalized and is ready to be dispatched. Once it's dispatched, there will be a gap between dispatched and when it's delivered to the customers. So the order status timeline is with created and finalized very closely, a bit of a gap with dispatched, and then quite a big gap with delivered. If you represent these in the form of events, you would see something like this. So these are all the same orders, so the order ID is the same, and you got the status, in this case with 4 different statuses that you can track. The most important thing is the timestamp. So if you look at the first one and the second one, they're only 4 seconds apart, right? And then the reason, let's say this is extremely efficient system to create an order and almost immediately finalize it. And then the one that was order dispatched, that you get, which is 30 minutes later, and then the actual delivery could happen at 10 o'clock the next day in the morning. Imagine especially these first two. If there's any delay in the message queue system, so every now and then these things do happen, and there's no guarantee of one thing would come after the other. What would happen is if the second one got in first, then the first one got in after, then you ended up with order created and you lost the order finalized situation. If someone on the other side is reading the API, they will see order created, but it's not finalized. So what's going on, right? So it'll be 30 minutes before you see the next one. So that's when it creates a problem, because the message has been delivered out of order. So let's talk about the order subscription of PubSub quickly. Although this is not going to directly solve a problem, it is still a powerful feature I think you should explore and understand and know how to use it. There are 3 things involved in using this. So first of all, keep in mind this is a feature that enabled at a subscription level. When you create a subscription, you can select the message ordering option to basically allow the message ordered using the ordering key. So what that means is the ordering key is now understood by the subscription to basically deliver the message in the correct order. But what exactly is the ordering key? The ordering key is something that you need to specify at the producer side when you send the messages to the topic, right? So I'll repeat that. It's something, the key you need to define at the point of the producer when sending the message to the topic. So there are 2 things involved in here. First of all, if you look at the Python SDK, in the publish options, you need to specify enable message ordering to true, right? Then it will allow you to send the ordering key later on, which is the second step. So this code I'll be showing you later, but basically you define what the ordering key is. So this could be anything, but basically the point of this is you want to use as a partition key, very similar to Apache Kafka. You want these different orders to go to different partitions, and then typically you can use the order key or customer key or whatever key that is unique, right, to that customer or to that order, and then later on these can be evenly distributed to different workers, and then so each worker can maintain the ordering of those messages, so it doesn't get out of order. But this is all you need to do to specify. So the bottom bit, that's actually a link. So this is an article written by Google back a couple of years ago. I read about it today. This is a super important article. So although I know I quickly go through this PubSub subscription with ordering feature, but if you are planning to use it on production, please read this. There's lots of important content, and especially if you scroll to the bottom, it actually breaks it down to streaming, pull, and also push. So there are pros and cons and restrictions on, especially when you enable message ordering. There are things you need to consider when using this. So it's not that straightforward. But let's come back for now. Okay, so as we talked about earlier, this does not quite solve our problem. Why is that? Let's consider this. So the challenge in analytics operations had been mentioning earlier, because of the upstream data processing and data modeling processes are a lot of the time these days delegated to the analytics engineering and data engineering teams. So those teams produce typically in data models that sits in BigQuery, right? So if you think about the problem here, these tools, right, especially dbt and Airflow too, you can do something called a full refresh or backfill, or you could make mistakes, right? So those processes, because it's quite fragile in a way that to repeat something has been done previously, and what that means is the backfill process here can happen. And what that means is if you do a backfill, a lot of the messages you produce, right, for let's say for all the statuses, they could be out of date. Depending on how the agreed way of tracking the deltas, and then it might not always be possible to actually accurately track the deltas at this stage. If it's not accurately tracked, what that means is the order of messages are wrong regardless, because if let's say if you resend something that has been already sent, let's say days ago, right, into the Cloud Run job, and that goes into the PubSub topic and then goes into the data store, things can go backwards. By looking this in a bit more detail, if you think about this scenario, right, so all I'm trying to explain here is you have already sent this four, right, but now you do a backfill or you do a refresh, and then suddenly all of these four messages have been sent to you again. Imagine what happens in there is you've got the first one, right? And then there's a delay in PubSub for whatever reason. Your order could have been changed from order delivered into order created, and that's wrong. Okay, how do we solve it? There's two very important components here in solving this problem. And as I mentioned earlier, if you use this approach for this scenario, there are other scenarios you may still need the PubSub subscription ordering. But with this approach, with the, let's say, the fulfillment system, all you need to do is to track the status of the latest, right? And then if you apply this, you do not need message ordering the feature from PubSub at all, right? So that is no longer needed. And all you need to do is to consider these two. First of all, logic. So if you use the logic to check the date or timestamp, right, of the business, so this is the domain date or timestamp. So in the form of those events, what that means is this date has to be not when the message is kind of landed to you for you to pull, right? But it's when the event of order created, finalized, dispatched, delivered has actually happened. Those are business domain timestamps, right? So those never change. Once it happens in the transactional systems, they don't change, right? This is very key. And so the key you want to, here is you want to do the comparison between the date you already have, right, for this particular order, for example, in a Cloud Data Store. If this is greater, right, if it depends on which one is actually more up to date. If the one in Data Store is already up to date, in this particular case, if you already have order delivered, in this case, at 10 o'clock on the 15th, if you have any of these coming in, they'll be written off. You don't need them anymore, right? The second thing is transaction support. So especially with the push subscriptions, as I mentioned, they're all HTTPS requests with extremely high concurrency and parallelization. And then this would hit problems if you have two trying to read and then write, and then if you one caught in the middle, you have a dirty read, which is out of date, and then you're trying to write based on the wrong information. So this is where transaction comes in. Data Store supports three kind of transactions, but the one in the middle is the default, and it's also the one I prefer. The optimistic one is basically saying if you have two processes trying to update the same key, right, and then one of them is going to fail, right? So when there's a contention, only one will be successful. And I'll be showing you the code later, what it looks like, but this is the two things you need to consider. One is the logic, one is the transaction. So what that actually put in context is, if you think about the first two, right? If these two somehow go into the trying to apply at the same time by two Cloud Run thread, trying to update Datastore at the same time, and then that is considered action on the same order, which is going to violate the transaction control in here. So only one of them is going to be successful, the other one is going to be pushed back. And the beauty of using the push service is it will basically just get pushed back to the PubSub message queue and then get redelivered. And when it gets redelivered again, it'll be successful or be discarded, right? Regardless, because you have the logic part to consider the timestamp as well. So with two both at the same time, with the timestamp comparison, you can see all of the other messages. If they try to reapply those, they'll be written off because the timestamp is out of date, right? So that's how this solution can be solved in here without even needing the message ordering feature of PubSub subscription. Okay, let's have a look at the code. This is actually quite interesting. So let me show you this to you. I want to show you how it runs as well, so you can see how the transaction contentions we're hitting it and how do we solve it. So I'll do this directly in the IDE, so it's a bit easier to just show you how this actually works. So first of all, I'm going to change this back to just looking at the message consumptions, right? So I have a producer. You can see here, which I've showed earlier. You need to enable the message ordering here to true to be able to do the ordering key thing here. And then all I did here is basically I have a message. I've got an ID. I've got a message content. I've got the ordering key, timestamp, blah, 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 right? So what this is basically saying is you've got 100 messages to send, and then the K is basically, in this case, the ordering key. I want to basically partition this by that. So the ISO format is here that is generating an entire timestamp. So let's try to produce some messages into the message queue. Okay, brilliant. Now we've got some messages. So this is the consumer. So let's walk through the code first. I've done two callbacks, right? So basically on the bottom is basically I'm attaching one or the other in the code snippet on this. You've seen probably plenty of PubSub consumer I've done in the past. This is a pool consumer, but it'll be the same on the other side. So this one I'm doing the ordering, but as I mentioned, if you're doing the solution as I mentioned with the logic and with the transaction control, you don't need to do the ordering at all. But this one is just, I want to show you how this works if you are using ordering, so you can see how this works in action. So first of all, this is just basically showing you some callbacks, right? So just print the message. Don't do this on production, but when you're testing out, it's quite handy. You can see what is coming out of this. The second one is about the transaction control. So let's walk this through quickly. The Datastore client transaction is using a with command is basically a statement is to opening the transaction. As you can see, the transaction is opening before I'm retrieving the actual record, right? So the entity here, what I'm trying to do is let's see if I can retrieve the record based on the ID from Datastore, right? If I can, then what it would do is to get the timestamp of the new message and get the timestamp of the existing message, do a comparison. If the message is too old, it will be dropped. Otherwise, it will just go ahead and do an update. If it's a new message, it will just go ahead and put it in anyways. And once this is all done, it will acknowledge the message and we're all good, right? So this is how it works. So the comparison here is the one we talked about earlier on the logic, and this one is the transaction control. So this one will make sure you don't have a dirty read. If you read a record halfway through and then you write the record, then it will be making the decision based on the wrong decision, the wrong data. Right, so let's try to run this with just nothing, right? And then this should show us it's just basically, trying to get the messages in and then consume the messages, right? So what I want to show you next is if I swap this around, right? Instead of using this one, I want to swap it with the transaction. So hopefully this will show you the contention. If I try to consume the messages again with the transaction, now you can see 409 aborted due to cross-transaction contention. This occurs when multiple transactions attempt to access the same data. So this is exactly what I would expect, right? In reality, you won't have this many, and especially when it happens, this is the limitation of the pull subscriber, because you need to handle these as well. Otherwise, your worker dies, right? And then it stops everything. But with the push subscription, it's actually much more handy, because if it does cause this problem, you just get an error, and then the message gets pushed, didn't get acknowledged, and it will re-push the message again. Then your contention gets resolved later on. So you only see this very often is because I deliberately generated this data with lots of keys are exactly the same, right? So to cause this problem. But in reality, it's quite unlikely this will happen. But I want to illustrate when it does happen, what is gonna do in here in this particular case. Okay, so that's all I wanted to show you in the code. Let's go back to the slide. Okay, let's summarize. So the 4 things I want to go through in the summary. So first of all, the combination of PubSub and Datastore for serving API is actually getting more common because, especially I would say in the Google cloud ecosystem, it's a very data-driven cloud. So a lot of your data is coming from the analytics pipelines and then modeled by the analytics engineers and data engineers. So that process typically happens with dbt, Airflow, and it goes into BigQuery. So the near real-time use cases of those data and coming from those data sources, you typically need to find a way to get into places like Datastore, right? Then on the other side, you can then serve these to the APIs. So this is actually a very, very common, actually getting a lot more common use case. That's why I'm showing you this design, and this is why this is important. So the PubSub subscription with message ordering, it is a powerful feature, but there's pros and cons. As I mentioned, please read that blog post that Google wrote, especially on the there's performance limitations on there as well, because one thing I found out is actually a lot slower than if you don't do the ordering. It makes sense, right? But also there's a specific limitations on the push subscribers, because it has to wait for the previous one to acknowledge before knowing when to send you the next one. So read that in detail before you put it on production. The message ordered in the message queue aren't always sufficient, right? As we discussed in this particular case, if you just get a message ordered in the message queue without putting some logic in place, just keep applying to the target, which is your data store storage by the key, then it could actually still go out of order, because a lot of these are dependent on the producing side as well, right? It's not like if you consume it in the right order, it would be correct, but it also depends on how the message are produced, how the delta is tracked, whether it's possible to identify the true delta, what timestamp you got given. So those are all the things you need to consider when designing this system. So finally, the logic and transaction matters, right? So when which Datastore fully supports, and then these things with the logic, which is the timestamp comparisons on the business timestamps, right? Which one is newer, which one is older, and then making sure you solve race conditions with the transaction controls, because otherwise the tool can still try to write at the same time. Even you compare the timestamps, it could have stale read, right? That could be making a wrong decision and still writing the things in the wrong way around. Okay, that's everything I want to cover today, and thank you very much. I'll see you next time.
Go out!